Hey, Math 10-C. Today we're going to look at solving systems of linear equations by substitution. Using graphing to solve a system of equations is an excellent visual tool. An alternative approach is to solve the system algebraically. There are two algebraic methods we're going to look at. The first is substitution. All right, so the method of substitution. Using the method of substitution, there are four general steps which are shown in the flowchart below. Step 1, choose the simplest equation and express one variable in terms of the other. Step 2, substitute the expression from step 1 into the other equation. So this is the idea of substitution, where the name comes from. Step 3, solve the single variable equation. And finally, step 4, substitute the solution from step 3 back into the equation in step 1 and find the value of the second or other variable. So consider the following system of equations: x plus 4y equals 17 and 2x minus y is 7. Solve the system using the method of substitution by rewriting the first equation in the form x equals. So we're going to say the first equation is easiest, it's the simplest one. We could have solved the second equation for y, but we're going to solve the first equation for x. So I'm going to minus the 4y from both sides. So x should equal negative 4y plus 17. Now, step 2, we're going to take this expression for x. So there's step 1. Step 2, we're going to take that expression for x and we're going to substitute that expression in for x in the second equation. So everywhere I see an x in the second equation, I'm going to plug in the underlined expression, negative 4y plus 17. So I used to have 2x minus y equals 7. But we know the value of x now is negative 4y plus 17. So that goes in where the variable x used to be. So instead of 2 times x, we now have 2 times negative 4y plus 17. And it's still minus y plus 7, minus y plus 7. So I've now got a one variable equation. This equation is in the variable y. So let's solve this one variable equation. Here's step 3. Solve the one variable equation. Multiply through by the 2. 2 times negative 4y is a negative 8y. 2 times 17 is 34. Minus 1y should equal 7. Combine our like terms. Negative 8y minus 1y is a negative 9y. And I'm going to minus 34 from both sides. So that gives me negative 27. And then divide both sides by negative 9. So y is going to equal 3. Step 4 says take that value for y that we just found and substitute it back into the first equation and find the corresponding value for x. So here's step 4. X plus 4y should equal 17. Well, we just found out that y is 3. So plug y in as a value of 3. So x plus 12 should equal 17, or minus 12 from both sides, x is 5. Now, they didn't put a step 5 in here, but a step 5 is not a bad idea. A step 5 is to verify or check. Verify in the equation we didn't do in step 4. So the equation we don't have in step 4 is 2 times x minus y should equal 7. So we're told x is 5, and we solved y is 3. 10 minus 3 should equal 7. Checks out. So my solution should be x is 5, y is 3. Or you could write it as an ordered pair, 5, 3. All right. Now, part B says, solve the system using the method of substitution by rewriting the first equation in the form of y. So the first equation is x plus 4y equals 17. I want to solve that equation for y. So I'm going to minus x from both sides. So 4y equals negative x plus 17. I'm going to divide everything by 4. So that's negative 1 quarter x plus 17 quarters. So I now have got an expression for y. That's that first step in solving by substitution. The second step says I'm supposed to take that value for y and substitute into the second equation 4y. So I've got 2x minus y equals 7. 2x minus y equals 7. So that's negative 1/4 x plus 17/4. Well, this doesn't look like it's going to be a lot of fun, but I only have one variable, so it should work. All right, so multiply through by the negative sign. So 2x minus the negative is like saying plus 1/4 x minus 17/4 should equal 7. All right. So 2x plus 1/4 x, 2 plus 1/4 is 9/4, 2 1/4. So I've got 9/4 x, and I'm going to add 17/4 to both sides, so that equals 7 plus 17/4. So 9/4 x is going to equal, 28 and 17 is 45/4. And now if I multiply everything by 4, I get rid of those denominators, so 9x equals 45, and then divide by 9, so x is going to equal 5. So you get the same value for x that we did in the top, so we know we've done all right. Step 3 says I should take that value for, that was step 3, solve that single variable equation for x. Step 4 says take that value for x and plug it back in to the other equation, to our first equation, and solve it for y. So x plus 4y is 17, x plus 4y is 17. So you minus 5 from both sides, and you get y equals 3. All right. And we said a step 5 should be verify. Well, we've done that earlier. All right. Check the solution using a graphing calculator. That's another way to verify. Okay, you can make sure that it works, but the solution should be 5 and 3. All right. Consider the following system of equations. 4x plus 3y is 0 and 8x minus 9y equals 5. Solve and verify the system using the method of substitution. All right. Well, look for the simplest equation. Well, the first equation, 4x plus 3y is 0, that's probably the simplest one. So let's take that first equation, 4x plus 3y equals 0, and solve for one of the variables. So it doesn't matter if I solve for x or solve for y. So if I solve for x, I'm going to minus 3y from both sides, and then go ahead and divide by 4. So x is negative 3/4 y. So that's step 1. We've solved one variable in one of the equations. So x now has a value of negative 3/4 y. Step 2 says I'm going to take that value for x and substitute into the other equation. So I've got 8 times x minus 9y equals 5. That's our second equation. Everywhere I see an x in that second equation, I'm going to plug this value in for x, which is negative 3/4 y. Now I've got a one variable equation, variable y. Step 3 says solve this one variable equation. So 8 times negative 3/4, if you do that in your calculators, negative 24 divided by 4, or 8 divided by 4 is 2 times negative 3 is a negative 6y. Minus 9y should equal 5. So that's negative 15y equals 5, and divide both sides by negative 15, and y equals negative 1/3. So that's the first part of our solution. Step 4 says we should take this value for y and substitute it back into the other equation and figure out what the other value for x is. So I got 4x plus 3y is supposed to equal 0. We know y is negative 1/3, so I'm supposed to go ahead and solve this equation for x then. So 4x, positive 3 times negative 1/3 is a minus 1, should equal 0. So I add 1 to both sides and divide by 4. So x is 1/4. Step 5 is verify or check. So make sure that this works. We know it works in the first equation because we found the second variable in the first equation, so we have to verify in the second equation. 8 times x minus 9 times y is supposed to equal 5. So we solved x as 1/4, we solved y as negative 1/3. 8 times a quarter is 2. Minus the negatives like adding. 9 times a third is 3. 2 plus 3 definitely equals 5. Once I've done my check, I can say the solution is x is 1/4, y is negative 1/3. You can't write that solution set until you've done your verification. All right? Example 3. Consider the following system of equations. Solve the system using the method of substitution. Well, these equations aren't very nice. We've got all sorts of things going on, so let's simplify these equations first. All right? So step 1, let's simplify them. 5 times 2a is 10a. 5 times minus 3 is a minus 15. So I've got 10a minus 15 plus b equals 5. Then I'm going to add 15 to both sides. So I get the equation 10a plus b is equal to 20. So I simplify that first equation. Let's do the same thing with the second equation. Multiply through by the negative 2. So 6a minus 2b, negative 2 times negative 4 is a positive 8, equals 20. So 6a minus 2b minus 8 from both sides equals 12. And I could actually divide everything by 2 there. 3a minus b is equal to 6. That's a good value, or that's the equation in simplest form. 3a minus b equals 6. So now I've got my two equations. I want to solve this system using these two equations. So it doesn't really matter which equation I want to choose the simplest one to solve for one variable. It looks like in equation 1 if I solve that equation for b. So step 1, let's solve that equation for b. b should equal minus 10a from both sides. And you get negative 10a plus 20. That's what b equals. So I've done step 1. I've solved one equation for one variable. I'm going to take that value for the variable in step 2 and substitute it into the second equation. So I've got 3a minus b is supposed to equal 6. But we're just told b has a value of negative 10a plus 20. So now I've got a one variable equation. I want to solve that one variable equation. That's step 3. So let's solve that equation. 3a multiplied through by the negative sign. Negative times the negative is a positive 10a. And negative times 20 is minus 20 equals 6. Combine like terms. 3a plus 10a is 13a. And let's add 20 over there. 13a equals 26. Divide both sides by 13. And a equals 2. Great. Step 3 says I should take, that was step 3. Step 4 says I should take that value for a, substitute it back into the first equation, and find the corresponding value for b. So 10 a's plus b is supposed to equal 20. And we're told a is 2. So 20 plus b is supposed to equal 20. Minus 20 from both sides, and b is 0. Well, the last thing you should do is verify or check. We'll call that step 5. So let's do a quick check or verification. I found my last variable in equation 1. Let's check in equation 2, but let's go back to the original equation. All right, the equation 2 original equation is up here. 6 times a, which is 2, minus 2 times b, which is 0, minus 4 should equal 20. So 6 times 2 is 12, minus 2 times negative 4 should equal 20. 12, negative 2 times negative 4 is a positive 8. 12 plus 8 indeed equals 20. It checks out. In that equation, it tells us here to verify in both equations. So let's also check in the first equation. So I've got 5 times 2 times 2a, a is 2, minus 3, plus b, which is 0, should equal 5. So I'm also going to check in this original first equation. So we've got 5 times 2 times 2, which is 4, minus 3, plus 0 should equal 5. 4 minus 3 is 1. 5 times 1 plus 0 equals 5. That is true. 5 plus 0 does indeed equal 5. So it checks out in both the original equations. At that point then, I should be able to write the solution. The solution is A equals 2, B equals 0. So you can't write that solution until you've finished verifying. Alright? Alright, so we've got this enrichment question. We'll do that enrichment question maybe in class if we get a chance. So right now I want you guys to do the assignments that the question you're supposed to do from numbers 1 through 8 on this assignment. Alright, there you go.